Hi and welcome. My name is Rafael Taubinger, and this video is about how to accelerate the migration of C, C++ code for ARM 32 to 64-bit with code analysis. So when you migrate from 32-bit to 64-bit, you can mainly reuse all your C source code, but of course there are some points that you should consider. So first of all, if you are migrating for example, a Cortex-A RM to, for example, a 64-bit architecture, you need to think about that you have two options. You can use the ILP32 data model, so that would be maybe the easiest way, but you might lose some of the biggest potential from using LP64, where you can address more memory. So as you can see in this slide, it's very easy to do the configuration or the available settings, but the principal cause of problems when you are converting 32 applications to 64-bit applications is actually the change of size in type with respect to long and pointer types. When you convert 32-bit programs to 64-bit, these types of course change size from 32-bit to 64. So this can of course cause a lot of trouble, and in this short video my plan is actually to give you some overview or some hints what you could do here. So if you look on this really nice list that I have here, there are of course many situations that can cause you a lot of problems when you're migrating your project. I mean, it starts with for example with sign extensions, structure packing. I mean, you can also have some string issue conversions, even some bit and shifts, magic numbers. I mean, there is a huge list that you should at least be aware or take care when you do your migration. But don't worry, there is actually a solution for it. And in order to accelerate the migration of C, C++ source code from 32-bit to 64-bit, we can highly recommend that you use code analysis tools. I mean, there is an automated way where you can check the syntax of your code, and it will point you some situations where this change from 32 to 64-bit might be a problem. You can do it statically, but also once you run your application, there might be some other issues that you might miss. So combining cstat and crun, for example, will of course point you all these issues, but also very important, a good compiler like the IAR compiler will already trigger some warnings in early stages. So it's almost like having all dimensions coming together, from static, runtime, the build tools, to provide you this best way to accelerate the migration. So, and now it's time for a demo.
So I have here now the IAR Embedded Workbench for ARM open. And I also have a very simple project that I already added here to the Embedded Workbench. Mainly I'm using some different cases. So very simple main with 7 cases that might happen in your source code, your C, C++ code when you migrate it from 32-bit to 64-bit. And what I'm going to show you here is that in these options, I'm initially, of course, compiling this code for a Cortex M7. It could be also a Cortex A15, but it's definitely 32-bit. So if I build this project here on the IAR Embedded Workbench, you will see that it builds completely fine. So we don't have any errors, any warnings. So this code is running completely fine with 32-bit on a 32-bit microcontroller. So now I'm going to move this to 64-bit. And first step is to select here a Cortex A53. You can, of course, also select, for example, a specific device like the NXP IMX8 or the TI devices from the list. But for this purpose, I'm using the generic Cortex A53. Next step, you also have the chance to work with a data model. So an easy step would, of course, if you are moving to 64-bit, And then you could, as a first step, maybe stay on the ILP32 data model. But that, as I mentioned before, you will lose all the potential that you have when moving fully to 64-bit with LP64, so you can address more memory and so on. So if I just select here the LP64 and confirm the settings, once I build the project, you will already see that if you have a good compiler, it will already trigger some situations that you should have a look. And we can already see here that a pointer conversion was already triggered. So in this situation, for example, what is recommended is, of course, to use a pointer type, for example, what you have on int types, and mainly you do some additional typecasting here to make sure that you use kind of a type that is large enough on what you are using in your application. So this is already one step. But of course, you could go over here, the source code, and do all the adjustments manually. But we know that nowadays projects are complex and they have maybe 10,000, 100,000 lines of code, and that might take a long time. And for this, what you can do is actually to use static analysis and runtime analysis checking. So mainly what happens if you, for example, use what here CStat makes available for you with a lot of standard checks, checking arrays, bounds, typecast, and so on. That's a really big help for you. Additionally, when you run the application, you might also be willing to do some additional tests like integer overflows, conversions, division by zero, or even some bound checking that you want to run here to help on the same time migrating your source code, but on the same time improving code quality. So very easy to enable it. And when I run the static analysis here over this project, we will see that many different combinations or many different warnings will be triggered. So the first one is actually already here on the beginning, and mainly if you are using constant types or that are used in constant expressions. So on the first situation here on line number 7, you can mainly see that it's complaining that this interval it's out of range for the shift operator, and the way to, of course, solve this is here on line 13. So you'll get, of course, the right result out of it here. If I move on here a bit further, we can see that it's also invalid pointer on 64-bit platform. And the next line, it's also access violation here that it's happening. So you can, of course, fix this, do the adjustments on the source code. But there might be cases because, as you might be aware, you combine static analysis with runtime analysis. It's almost like a matrix where the two cover each other. And then, of course, the tools like the compiler here and the linker come on top. So you have all possible dimensions to get out syntax errors or errors on your logic. So since I enabled here the runtime analysis, just to recap here, it's enabled. What happens here is when I build the project, and I already did that, it will instrument the code. And once I go to a debug session here, with this instrumented code, we will be able to detect any errors or problems. So I'm just running the simulator here in this case, but you could run it on hardware directly. So if I step in here on the cases, we already have that situation as we saw before. That was triggered by static analysis. So complaining about the shift here with the signed value. But if I go to case 2, we will see actually that it just passed, no situation or has been triggered. If I step in here on case 3, everything looks good, but there will be, of course, an access violation here. It's out of bounds that have been triggered. So as you can see, it's really useful, and if you fix all these situations, again, even if we already fixed here the size of the pointer, that it's big enough for this case, there are still some situations that you need to cover here. And of course, this is very powerful. It helps you to find any tricky situations in the source code in an automated way. So as you can see, very easy. You just enable static analysis, runtime analysis, and it will point you specifically which parts of the code you should take care to make sure that you have a smooth migration.
And as you can see, it's really important to consider code analysis tools, first for code quality, but also if you want to accelerate migration, that's of course a shortcut for you. Make sure that you have access to static analysis and runtime analysis, that's CStat and CRUN. Thank you.